So, good evening, everybody. I am Debasis. I'm a software developer on the voice team at Twilio. I've been with Twilio for about 6 years now, long timer. In terms of software industry, 6 years is long. So, yeah, from the beginning, I've been with the voice team. I have changed probably 3 different teams, but all in the voice team, all in the voice subdomain. So, I'm here to talk about chaos engineering, and mostly I'm going to focus on game days and past outages that we have seen at Twilio, past outages with respect to the voice team. And voice outages are pretty sensitive. Like, if you're trying to play a Netflix video, then you press play, it doesn't play, you see a circle. What do? You refresh. There's a very good chance it is going to play. But in terms of a voice call, what happens? You try to make a call, it doesn't connect. Then you say, fine, I'll try again. It doesn't connect. The tolerance of connecting or hearing a callback tone is mostly between 10 to 15 seconds. So that's when mostly humans are impatient. So if you don't hear a ringback tone, or if you don't connect the call in 10 to 15 seconds, you say, Twilio sucks, it doesn't connect, what's going on? So yeah, so today I'm going to talk about how we maintain resiliency of the Twilio's voice stack with focus on examples of past outages. So let's move forward. How many of you are aware of what Twilio is or what Twilio does? Wow, pretty good. We are popular. Okay. So, just for sake of brevity, Twilio is a cloud communications platform that enables API that enables communication channels, voice, text, video, and chat through APIs. So, Twilio as a communication platform has powered more than 2 million devices, and the same number, it's actually a little confusing because 2 million developers have powered 2 million devices. So it's, if you make a combination of 2 million developers working on 2 million pieces of devices, I don't know what the number would be. It's a huge number. It's a very big number Twilio has reached now. So programmable voice, text, and video, these used to be owned by people like Avaya, Cisco, WebEx, and all the monoliths. Or anyone from Cisco or Avaya around here? Okay, thank God. Don't beat me for it. So yeah, so it used to be on-premises equipment, and it used to be a solution built, custom built for you. But Twilio changed all that by exposing the same things via an API. So any developer with access to a SDK, Twilio SDK, can make communications, make phone calls, receive text messages, and make a video conference. And that is probably, this happened probably after maybe 90 years of first phone rang. When was Graham Bell? It was 1900 something, probably early 1900s. So almost 90 to 100 years after the first telephone rang, I wouldn't say me, but developers were exposed to APIs. So it's a pretty interesting analogy what we were doing for 90 years. Yeah. Anyways, so Twilio runs on AWS, as everyone knows. AWS has multiple regions. We run on 8 different locations or regions, I do say, in AWS terms: Oregon, Virginia, Sao Paulo, Ireland, Frankfurt, Singapore, Tokyo, and Sydney. So these are 8 regions Twilio runs on today. There are more planned, but yeah, let's not get into that. So, okay, is everyone aware of AWS terminology, basics of AWS? Most of you? Okay, cool. So AWS has something called AZs. Each region consists of multiple AZs. An AZ is availability zone, which is an isolated location in a region, and each AZ is interlinked to other AZs through low latency links. Don't ask me what these low latency links are, but that's what they define, and they're pretty fast. We have tested around, mostly it's a Gbps link, and they're pretty reliable. So let's jump on to how a Twilio cluster looks like, the Twilio's voice cluster. So you would be seeing there's a small tiny diagram of carrier, IPPBX, SIP-LB, B2B UA. So these are actually the components of our SIP voice stack. So just ignore, just call them app A, app B for clarity. So all these applications are a part of, it's an oversimplified view of the voice cluster. So most of you would know VoIP calls are handled or routed using SIP. SIP is Session Initiation Protocol. Is everyone aware of SIP or knows a little bit about SIP, what it is? Okay. Okay, I see Nathan doing. Okay, so SIP is a IP signaling protocol which is used to establish, modify, and terminate VoIP calls. So if you are having a soft client or a VoIP app on your phone, there's a pretty good chance it uses SIP to talk to other VoIP agents, VoIP apps or clients or servers. So what you see in the picture is actually a simplified cluster view of the voice stack. Now, since I said SIP is pretty popular in the VoIP world. SIP is pretty powerful, and SIP is also difficult to manage because it is stateful. Okay, I don't see any frowns. Stateful, because people mostly working on REST or HTTP, if you say stateful, they hate it. That's why SOAP was SOAP was so unpopular. I mean, it was popular, but yeah, I would say people like us were like having a nightmare dealing with it. So yeah, so a SIP call flow, if we are trying to make a call, is very briefly or very on a high level looks something like this. Alice calls Bob, sends an invite, receives 100 trying, receives 180. 180 ringing is what you hear, the ringing tone. Once Bob picks up the call, then it sends a 200 OK. That means I picked up the call. Then that is followed by an ACK from Alice saying, hey, I received your 200 OK. And then after these many exchange of messages, then there is media. Then you can say hello, and the other side would hear it. So it's a pretty intricate set of messages, and this is just an overview. There are STPs, there is what kind of codecs you want to use, it's an audio call, it's a video call, what is the quality of the call. There are so many things involved. Let's not get into that, but this is complicated quite enough. So you saw how complicated, I would say how many components are there in a voice stack. So how do we monitor the cluster, the voice cluster? We have health checks, both external and internal. We have metrics dashboard that we publish data metrics to FlowMill and Datadog. We have 24/7 end-to-end testers across all regions that I just talked about. Then we have application log monitoring using Rollbar. And so these are the ways we monitor cluster, but there are some inbuilt tools that we use to determine the health of nodes and take evasive actions, like automatic recovery. So we have instrumented or automated one internal cluster monitor, which if a server or a host deems unhealthy, maybe due to an internal or external health check, then there is automatic swapping. Automatically it is recovered, automatically it is swapped out, and a new one is booted, and your cluster comes back to the same state as it was. Then we have auto scaling. Auto scaling means, as the name suggests, given the time of the day and the amount of traffic the voice cluster is seeing, we scale up or scale down our size of the cluster. That means if 50 servers are needed to process 150 calls, when 150 calls per second reduces to 100, we reduce our cluster size. And maybe save some money on our AWS bill. Okay, so now let's take a look at real outages. What outages Twilio's voice team has seen. As I was saying a little earlier, outages in terms of voice is hello, drop. That's what a outage is. Well, I'm not counting the automated calls like, this is bank so and so calling, please leave me your number. I mean, not that. It's human tolerance I'm talking about, and that's what we program to. And voice tag is pretty sensitive in this matter, because if one app or one of the applications is having trouble, then it is a ripple effect through the entire cluster. So that is something which is different from a streaming or from a billing, you can say, or analytics backend, because they can be little tolerant. You can have retries. You could have retries to publish the metrics, but you cannot have a retry after 5 minutes of making a call. Suppose you pick up your phone, you call somebody, it's not connecting, drop. Then after 5 minutes, the other guy receives a call. Oh, hello, yeah, what's going on? Somebody called me. Hey, did you call me? So that would be weird. So the point is the tolerance is pretty low. Hence, we call it real-time communications, RTC, in our the famous RTC and everything related code name. All right, so past outages. What voice team has seen so far? I mean, it's not an exhaustive list. This is the top 3 I'm just going to mention. AZ outages. As I was just saying, AZ is isolated region in a AWS, isolated location in a AWS region. We have seen AZ outages as a number 1 reason or number 1 factor contributing to our downtime. DNS outages. DNS outages, the name suggests, you cannot do a DNS name lookup and your name server is not reachable, and hence you cannot do anything, basically. Then black holes. This is my personal favorite. Black holes, they exist. You very well know there is something happening, they exist, but you cannot find out, because there's not enough data to point this thing is happening right here in the cluster. So this is my personal favorite, but I'll get to it a little later. Let's start with AZ outages. So 2 types of outages. One is complete outage, like 2 AZs in any 2 regions. They simply cannot receive or transmit any kind of packets. So it's a total blackout. And the other one is partial outage, which affects only one route. So as you can see, in the one on to your left, the picture on your left, that's a complete outage. All the routes are dropping packets on 2 AZs on the left, and on the right, you can see only one route is affected. That's a partial outage. So everything kind of works, but not really. It's like, yeah, it works, but in a degraded mode, which is, again, not a great thing. So let's dig deeper into my favorite one, which is the partial outage one. That is harder to gauge the impact. You would see a drop in packet, you would see a drop in percentage of calls or CPS, but you wouldn't be able to figure out what's actually going on and how much packet I'm losing, and that is causing this. So let's dig deeper into it. Not typical, let me say this. This is an actual outage, actually. These slides, I have edited the numbers so that Twilio doesn't come after me saying, hey, you exposed our internal numbers. So yes, so we have these dashboards in place with key metrics. 2 a.m., pager goes off. What do? Engineer takes a look at these dashboards. Voice Edge, US looks okay, green, EU, green, South America, green. Australia is deviating a little bit. You see that yellow color, so we have color coded it. Yellow is something going on there, something fishy. Red is something is blowing up. So if there was a complete outage, you would see this entire thing dropping to maybe I don't know, some CPS, but it would be in red. Everything will be blowing up. Health checks, cluster monitoring, metrics, everything would be blowing up. And you would know. It's easier to detect. So 2 a.m., the pager goes off. You look at this. Then you might think if it's your lucky day, then it's a false positive. You see, okay, it's a false positive. This number comes back to normal ranges, goes green. Resolve, sleep. Okay. This is not the normal day. This is not your average normal day. So what happens? You jump onto the end-to-end tester's dashboard. The end-to-end tester dashboard show there are some sporadic failures, but not everything is falling apart. Then you try to guess what's going on really. Okay, since I have already said this is a partial outage, it makes sense because it's a partial outage. Some packets go through, some packets don't go through. So that's why sporadic. Not everything is falling off, but some tests are failing. Then you see what tests are those. Everything is pointing to Sydney. So all the tests that have failed between this time, you see there is uptake in Sydney and everything, uptake in failures, and everything is Sydney. So what else you can do? At this point, we don't know what AZ or what is going on. Enter flow mill. This is an actual graph from the outage on October 23rd or 24th. Is there a date here? No. 23rd or 24th of 2018. So this is an actual outage showing traffic between AZs. So you take a look at this graph. There is one line, this little outlier, like little bit higher than everything else. That line is basically AB Southeast 2B, Sydney, to US East 1D, Virginia. So this is nothing but an uptake in retransmissions. Because SIP is stateful, SIP is internally SIP is on UDP, and since SIP is stateful, we transmit an invite, the one I just showed earlier, like there's a series of exchanges going on. So there's an invite transmitted, and then if you don't get a response back, 100, 180, or 200, you keep retrying because it's SIP, and that's what it makes it pretty powerful. That's what makes these things also go crazy because they can jam up your network. So yeah, there are retransmissions, and you see, something is going on. Then you take a closer look. Now we know, okay, Southeast 2B, Sydney is affected. What do we do? Remedy? Evacuate the AZ. Simple, right? Except evacuating an AZ is pretty expensive because you have DNS records to deal with, because you have hundreds of hosts you need to take out. That will deplete your cluster capacity. And the same number of nodes or servers you take out here, you need to boot somewhere else so that your cluster capacity remains the same. Otherwise, everything else is going to blow up. It may not sustain the load. So AZ evacuation, we have seen it. We do have automation around it. With a flip of a switch, we can evacuate an AZ. But there are the pitfalls. I'll show you why it is a bad idea now. The other option is reroute traffic to another AZ. Again, I just said you have to boot the same capacity somewhere else. Otherwise, the capacity, if you don't have enough capacity, it's going to jam up your network. It will jam up your cluster altogether. So AZ evacuation, rerouting traffic to another AZ, both kind of work. For both the scenarios, we have automation around it. But then what? Let's look at. Sorry, I just spoke over it, but this is what was supposed to show you. Reroute. Okay, anyways. So take a look at this graph, another flow mill graph, which shows if you put the right filters, it will show you the traffic between individual hosts. So the graph you are seeing is the traffic between individual hosts between AP Southeast, Sydney, and Virginia. So, I need not say, you must be seeing a small blue line, like an outlier. So what's going on here? So I admit we had this data, but we did not look at it during the incident. because we did not know this is a dashboard that we can also like put filter. I mean, you can have filtering on hosts, and you can have a dashboard like this. What happened was we ended up evacuating the AZ, very expensive, took a while, took all the decision went all the way up to the VP of engineering, because AZ evacuation it is not fun to put it that way. So we found this graph in retrospect when we were looking at the incident, and this graph is running on my laptop right now 24/7, because if something like this happens, then I take a look at these kinds of things. Well, okay, so if we the point of showing you this graph was, if you have the right metrics, we know this is the host which is having issues in that AZ. Replacing a host is just like that. You just press a switch, replace, done. One click. We could have avoided all the AZ evacuation, all the drill, all the drama, all the sweat, all the cursing, and whatnot, everything else. So, yeah, anyways, but I cannot stress enough how important it is to have the right metrics when things go off, when things blow up. Okay, let's jump to DNS outage. Name says DNS outage. You cannot do any DNS query and forget about routing any traffic to anywhere. So if you are experiencing DNS latency or DNS outages, it affects anything going out of your host or anything going out of your server cluster. It includes out of your cluster into customers' equipment, such as suppose you are trying to call biloxy.com. Let me show you. So in this AZX is having issues, and AZY is the one where it is trying to reach to. And simultaneously, there are some webhooks that you are trying to do. There are some web use cases. I will not dive into that, but you're trying to reach biloxy.com, a customer's webhook. So if you're having DNS issues, then it's basically you cannot talk to the other AZ to process your call. You cannot fetch your webhook or your customer's configured webhook. So what happens? It's pretty useless. The AZ is pretty useless now. And you would say, point to a different DNS server, which is practically a solution. I mean, theoretically a solution, but practically you have to change host name server on each and every host, and that's not a fun exercise. Other option, well, you have third-party DNS servers. You could just point to a different one. This is the problem with Amazon. I mean, each region or each AWS AZ has their own DNS servers. We don't really have access to them. As people are aware, I mean, people who have worked with AWS, they would know the AWS routing happens through host names. There are no IPs, it's host names. The next hop is always a host name, and that is translated into an IP. It looks like an IP, but it's always ec2 blah 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 .aws.com. So it's rendered pretty useless. So the only option you have, and it happened to us. Does anyone remember there was a huge outage on the East Coast, May 2018? Yeah, roughly. Yeah, Nathan says, yeah, I know, I've seen that. Okay, so this is what happened back then to us because of Virginia. Because of the Virginia data center, everything went black because you cannot just do anything. So we had to take that out, evacuate the entire AZ, and as usual, it wasn't fun. Now, again, I cannot stress enough. We didn't have this metrics back then, but not retrospect, but some other team which had the data, we saw exactly what happened. If you take a look at the graph on your left, look at number 1, increase in DNS packets sent out. So when the DNS outage happened, our servers, when trying to route a request, were trying to send out DNS requests. And basically, the issue was the DNS servers were attacked, or maybe they were DDoSed. I don't remember. Does anyone remember what happened? Anyone? No? Okay. Anyways, okay, they didn't respond. That's what was the point. So you see an uptick in packets sent, but on the right-hand side, you would see there was no response received. There was no uptick, or there is no change in the responses received. So definitely, this shows there is something going on. The packets are being sent, but you are not getting a response back. And at the end, if number 2, DNS packets return to normal when the issue was resolved. So you see there's an uptick in the retransmissions because the hosts are retrying to resolve. Then when the issue, the DNS was restored, then you see all the normal ranges, the DNS queries return to normal ranges. So again, this is to stress, right metrics can and always have resolved or reduced the mean time to recovery. And I'll show you, Homing talked about humans. I'll talk about humans in a little bit. So black holes, this is, I will admit, it's a very difficult one. It affects a particular small set of hosts in one AZ. Inside that AZ, it doesn't have to go out anywhere. It's inside the AZ, and it's a small set of hosts. You know there's something going wrong, but you just can't figure it out because it's one route. The next health check or the next call or the next packet makes it. And you think, okay, it's fine. But if there is enough packet loss, or if there is enough latency, then the health checks would kick in, internal or external. One of the health checks would kick in, and our cluster monitor, it would replace the host. But this small drop in traffic, the small percentage, will keep the health check flapping. Once pass, once fail, once pass, once fail. So our clusters cannot really know, cluster monitors cannot really know what to do with this. Is it healthy or not healthy? So we could take it out because it is flapping, but then again, there's a thin line. We are not entirely sure if this happens on a bigger scale, then it's probably trying to get half of the cluster out of load balancer at the same time and trying to boot half of it at the same time. What this will do is this will render our capacity half while doubling our AWS bill, because you cannot shut it down because the health check is flapping. But you have another half of the host, like say we have 100, we are taking out 50 out of load balancer, we are booting 100. So it's like 150 nodes now instead of 100. So it's little dangerous. But given all these things, what we have seen as of today, I can confidently say having the right metrics during an outage cuts down your mean time to recovery drastically. So I showed you what the flow mill graph did. So right now we have AZ to AZ pings running dashboards like these monitors in Twilio. If you walk into Twilio's HQ, you will see these kinds of monitors pinging, showing dashboards for AZ and inter-AZ, intra-AZ, and inter-region pings. Okay, so we went through AZ outages, DNS issues, black holes. Yes, black holes is still work in progress. We haven't found a good way of determining a black hole. You saw AZ outages and DNS issues were pointed out by flow mill graphs, flow mill metrics. Black holes we haven't had the opportunity to figure out or point out a graph in flow mill to show reliably a black hole. I guess I'll be after you guys. All right. So Homing gave you gaming examples. I'm going to quote you something from movie. Anyone recognize this? Mostly, probably everyone. So let me put it in a software engineering perspective or a chaos engineering perspective. Shit happens, we know. We are on AWS. Someday AWS engineers decide, okay, it's time to upgrade our network. Fine, plug it out. What would you do? I mean, you just can't control it. Shit happens. So what matters is how fast you recover and how well you learn from the outages. And if shit happens, then RFEs will happen. customers will ask for RFEs. So well-crafted, well-informed, and a well-crafted informational RFE, pardon me, builds customer confidence. What does this mean? You as a customer ask AWS what happened on this day, this time. You send out an RFE saying, oh, something went wrong with AWS DNS servers on that day. Versus on 31st of January, between 10:33 to 10:36, Amazon's East 1D DNS servers were having issues because of a faulty upgrade. So they have reverted since then, and the issue is resolved. Which one inspires confidence? The second one, of course. So you learn from these outages, and if you have put together an RFE, or if you convey to your customers that, yes, this is what happened, this is what we are doing for it to not happen again, that inspires customer confidence. Customer trust is what, I think Homing also had a slide saying, you cannot put a dollar amount on it, but once customer trust is depleted, it's very hard to regain it. So apart from everything else, this is what we have learned from the past outages. Customer trust will deplete, but with a well-crafted RFE with the right information, it may not be, the customer will still trust you with their production traffic. Okay, so enough of outages. Now game days. So I believe if you guys are here, then you believe chaos engineering is important, and running game days is crucial to any cluster's resilience. Now, we are not Netflix yet, so we are not running chaos in production. But yes, we do have game days. They are iterative. We have game day. We plan to do game days every quarter, at least once. And since our cluster is also, they are evolving every day. Every month we push around probably 80 to 100 upgrades of various softwares. Let it be SIP, let it be you say TLS, let it be like supporting HTTP 2.0. So we constantly upgrade our servers, we constantly upgrade our cluster, and upgrading your game day or running your game day and upping the game is also important. So game days are also important if you are relying on someone else's hardware, like the cloud. You don't control the hardware. You know they will pull a plug someday without telling you. What do you do then? I mean, no, don't plug out, plug it in. No, you cannot do that. So that's what you prepare for. Twilio has 4 nines. As of today, we guarantee an SLA of 4 nines. What does it take to achieve 5 nines? Well, there's a graph. 4 nines is 52 minutes per year, and 5 nines is 5 minutes. Okay. A typical outage or an incident in Twilio's voice stack lasts for mostly around 10 to 30 minutes. It's a wide range, I know, but depends on the nature of the outage. So out of this 10 to 30 minutes, 5 minutes is spent notifying the human, notifying the on-call engineer. Because, the health checks and everything, that they kick in, and if there are consecutive failures or multiple things correlate, then you page an engineer. So it takes 5 minutes to page an engineer. And 5 nines is 5.26 minutes a year. So one incident, there goes one of your nines. You're back on 4 nines. Is it possible? Yes, it is possible. But it takes a lot of planning, a lot of automation, a lot of, what you can say, taking out the human part from this interaction. So the less a human is involved, the more faster it is. Because humans are not slow. I mean, they're slow, but they're fast, or they're good in making faster machines and faster algorithms. That everyone agrees, I think. And the purpose of a game day. The purpose of a game day is self-healing networks. Through AI, before anything happens, we detect it and we stop it. Nah, I was just kidding. No, not really. Maybe soon. But we don't have AI to detect failures before they happen. We have some stuff like nests. They learn from what you have done in the past to predict what you will be doing. Like the thermostat just switches on at middle of the night because I set it the day before. Why? Because I was working. I'm not working today. Why do you want to heat me up? But yes, that's not there yet. Soon. Our goal at Twilio is self-correcting cluster. If shit happens, take corrective measure, take evasive action as soon as possible, as fast as possible, and heal the network, or let's not use the word heal, restore the network to its original capacity or state as soon as possible. How? Reduce time to recovery by reducing human interaction. Because as I said, it takes 5 minutes to intimate a human or the on-call engineer that something is wrong. What does the on-call engineer do? It looks at certain stats, flow mail, Datadog, logs, and whatnot, and correlates. And they then takes a decision, flip the switch. I mean, if a human can read it, if you are able to consume the data to correlate and do something, a machine can do it. And a machine can do it much faster than us. And we have to design it, but yes, it can do it much faster than that. Well, humans are slow, but yeah, maybe I should have taken that out. Humans are better at producing faster systems than they themselves are. Now, a typical game day at Twilio. As I said, we haven't run game days on production yet. We run it on dev. We run it on our development environment with a virtual partition. A virtual partition is nothing but you boot a cluster and you want it to interact with its upstream and downstream roles in the same virtual partition, but not affect others, not affect other traffic. So environment prep, select the roles or clusters we want to test, we want to run the game day on. Determine the scenarios. These are the scenarios we decided or we arrived upon in our last game day at Twilio, which was a couple of months ago. Inter-AZ complete outage, I just talked about it. Inter-AZ partial outage, same thing. Increased latency, what happens when your server is subjected to increased latency. DOS and DDoS, this is applicable to edge routers or your roles which are sitting on the edge interacting out to the outside world, and DNS outages. DNS outage I already spoke about. Then we develop scripts to mimic the degradation. So these scripts utilize IP tables, mostly IP tables, to control the behavior of the networking equipment underlying, like controlling the packet loss rate, like you could set to 100% packet loss, or you could set it to 10%, you could set it to 1%, or introduce latency in the stack. And all these scenarios I just said can be done or can be achieved with these scripts. So this is what a virtual partition looks like. I just explained already, but yeah. So a virtual partition is a cloud inside a cloud. We just don't, you interact with the upstream and downstream services in your cluster. You just don't go out of your cluster or the virtual partition. Tools we use are the same ones we use in production. Datadog, Flowmill, Rollbar, Lightstep, and of course end-to-end tests running in the chaos environment. Lightstep is what we use for measuring the performance of the app, but we don't really rely on it because SIP, as I said, is way complex than HTTP. It has states, so Lightstep sometimes gives you different metrics because it's in a certain state. It is supposed to be, but it is not really meant for that. So And yes, of course, the last step in any game day, learnings and improvement. It's funny because today we had a discussion at Twilio on my team to do a game day, and we just talked about all the points here, enter easy complete outage, everything else. Then the interesting thing is what happened in the last game day. We planned all these things, but as Ho-Ming said, you don't know until you run it. We started our game day, probably Mike and Jonathan know, I told them already. We started the game day, and first step, everything fell apart. Why? Because there was a unexpected routing issue. I wouldn't say an issue, but unexpected routing behavior that we never thought could occur. Because I said SIP is stateful, it has retransmissions and routing based on route headers. And that basically stopped us from doing any of these things. We planned it, but we couldn't really achieve any of these because that is the step one. And since we fixed it, and this is what we are going to do the next game day. So I just shared a learning and just shared an improvement. What else is remaining? I think that's pretty much it. If you are here, then I pretty much believe you believe in chaos engineering. And I cannot stress enough, if you're in a cloud, how important it is to run game days, how important it is to have the right metrics and have the right dashboards to look at when there's an outage. Any question and answers welcome after this, but over to Jonathan.